In this video I'm going to do an example of drawing a cubic from factored form. The cubic that we're going to look at is y equals x minus 1, x plus 1 times x minus 2 times x plus 3. To draw a cubic, or rather to sketch a cubic, we need to determine our x-intercepts and our y-intercepts. We need to remember, key point, x-intercepts occur when y equals 0, and y-intercepts occur when x equals 0. We can easily determine our y-intercept. We set each of our x's to 0, and that means we end up with 1 times negative 2 times 3, which is negative 6. So our y-intercept is going to be the point 0, negative 6. We can also relatively easily determine our x-intercepts. We set y equal to 0, and we have our three factors, which are called linear factors, because if you made them equations individually, they'd be straight lines. To get an answer of 0 when these factors are multiplied together, 1, 2 or 3 of them must be 0. So our x-intercepts occur when x plus 1 equals 0, or x minus 2 equals 0, or x plus 3 equals 0. I like writing them out like this because it makes it clear what I'm working out. I can just solve these little equations and that will give me my x-intercepts. Sometimes these equations are going to be very easy to solve. Occasionally they're going to be very difficult. But in our particular case they're easy. So I have my 4 intercept points. I need one other thing to determine the approximate shape of this cubic, and that is to find out whether this cubic is positive or negative. To determine whether it's positive or negative, I need to take all of the x values and multiply them together, including anything out the front. So if there was a negative out there, I'd have to include that too. There isn't in this case. X times x times x gives me x cubed, positive x cubed in fact, which means that we have a positive cubic. That's basically what it means. The cube is positive, so therefore I have a positive cubic. If we look at that graphically, what it means is we're going to start our cubic there. It's going to curve in some fashion like that, say, and it's going to end down here. If we drew a straight line between those two parts, we'd end up with a line with a positive slope. Again, a clue that we're dealing with a positive cubic. So I have my x-intercepts, I have my y-intercepts, so now let's see if I can draw some kind of sketch. My y-intercept was way down at negative 6. I had an x-intercept at 2. I had another one at minus 1. And I had another one at minus 3. I know I'm starting in the top quadrant, so it looks as though I'm going to be heading somewhere down like this, and then back up again, and then down again. So if I go something like this, that should be my cubic, my rough sketch of my cubic. If we look at this cubic done properly in GeoGebra, we can see that I got it approximately right. I probably didn't go far enough up here and far enough down here when we're comparing our two graphs, but we're looking at a rough sketch, so that's fine. The one way to determine how low and how high we end up with is to find the center of the intercepts, because we're going to have a central line and that's going to be where our turning points are. But for the purposes of sketching a graph, we don't really need to worry about that at this stage. So that's our example of sketching our cubic equations. I will make a couple of other videos that talk about sketching cubics that are in different forms. For example, that, or that. These are slightly different. You may remember this one bounces, and you may remember that this one wiggles. But I'll look at those in future videos.